Thank you guys for joining the session. Okay. Banupriya, are you available? Okay. Thank you for joining the session. Priyadashni, start with the welcome speech.
I'm delighted to have a privilege of introducing today's speaker, Ms. Banupriya. She is a diver and a passionate individual, making a significant strides in the field of embedded system and IoT. As an inspiring engineer and IoT enthusiast, she brings in a wealth of knowledge and hands-on expertise in the cutting-edge technology. Additionally, she is an entrepreneur and emerging speaker, eager to share her insights and inspiring others. Today's webinar, Ms. Banupriya will be walking us through the fascinating world of embedded system and IoT, exploring how these technologies and shaping the future of innovation. Her expertise combined with her practical approach will provide all the participants with the in-depth of understanding of the subjects, along with the valuable knowledge applicable into the real-world scenario. Beginning her technical experience, Ms. Bonapriya has the extensive experience as a speaker and has successfully organized various events, showcasing her leadership and a passion of knowledge sharing. We are happy to have her with us today. I am confidently her session will be both informative and inspiring for everyone. Thank you.
Banupriya, you can start the session.
I'm audible?
Yes, Banupriya, you are audible.
Okay. Good evening, everyone. Hope you are all fine. First, I'll introduce myself. I'm K. Banupriya, a third year BE Electronics and Communication Engineering student from Adiparashakti College of Engineering. And today I am thrilled to have the opportunities to speak with you about exciting and transformative technologies, embedded system and IoT. Let's start by understanding what is embedded system. Embedded system is nothing but a combination of hardware and software system which is built in a single component that controls specific tasks within a device. We are daily interact with the embedded system without realizing it. Even it's in your mobile phones, cars, etc. All the devices are built with embedded system nowadays. Let's see some common examples of embedded system, which include smartphones, washing machines, microwave oven, automated systems like anti-lock braking systems and airbags. Examples for medical devices like pacemakers, insulin pumps, and in industrial side, robotics and process controllers. Then we move on to the key components of embedded system. In any embedded system, there are several components of it. The main components are microcontroller and microprocessor. First, we see what is microcontroller. Microcontrollers are compact chips with built-in memories and input-output peripherals. While in microprocessor, we need external components for memory and IoT functions. And other key components of embedded systems are memory, sensors, and actuators. For memory, ROM and RAM, sensors used to collect data from the environment, and actuators which converts electrical signal into physical action. The memory is the storage component, sensors are the input component, and actuators are the output components. Now see embedded system architecture. The embedded system architecture is built by hardware and software layers. In the hardware layer, it consists of system on chip, memories, and peripherals. In the software layer, includes device drivers, an operating system, middleware, and an application layer. Each layer has specific responsibilities and interacts with the layers above and below it. This modular approach enhances better reusability and maintenance over a period of time. We see types of embedded system. Types of embedded system can be categorized into three different types based on their complexity: small scale, medium scale, large scale. Uh, Small scale system is a simple standalone system. For example, calculators. In middle scale system, it's a more complex with real-time operating systems. For example, home automation system. And large scale system is a higher complex networked system. For example, industrial controlling system. Real-time system overview. The system must respond to the input with a specific time. Every system has a specific response time. If the response time of the system increases, then the people not prefer to the product. So we have to design a product with fast response time corresponding to the input. Now let's explore a few popular embedded platforms you can use in your projects: Arduino, ESP32, and Raspberry Pi. Now let's see the pros of each platform. First, Arduino. It is favored for beginners due to its ease of use, large community supports with plenty of tutorials in social media, and wide range of compatibility sensors and modules are used. Second, ESP32. It is excellent for IoT projects because it comes with built-in Wi-Fi and Bluetooth. It is more powerful than Arduino with dual core processors. The cost of the microcontroller is very low and it offers greater energy efficiency. The final, Raspberry Pi. It has capability of running a full OS. It is a more advanced option for projects requiring high processing power. Hostel with USB, HDMI, and other connectivity options are available in this platform. Each platforms have some disadvantages based on their project and use. Now we see what also. In Arduino, it has limited processing power. It has not suitable for complex applications, and in ESP32, learning process is compared to difficult to the Arduino. Fewer ready to use libraries and community support. In Raspberry Pi, higher power consumption compared to microcontroller is too much for basic embedded tasks and complicated to set up. Okay. How we move on to IoT. The things which are works based on the internet is called IoT. The IoT allows device to communicate and share data over the internet. IoT connects the physical world to the digital one. It is a integrated platform of many things, from smart thermostatics to industrial robotics. Let's see an example. Virtual assistants like Alexa, if we give command to turn on the light, then the analog signal is converted into digital signal through microcontroller. Then the light is on. Like that, the devices are communicate with each other. Now we'll see history of IoT. In 1999, Kelvin Haston coined the term Internet of Things while he worked on the project related to supply chain optimization. In early days, Coca-Cola vending machines were placed in various locations, dispensing drinks when coins were inserted. However, stock shortage leads to reduce the profit. To address this, the idea of connecting devices to internet emerged, allowing real-time monitoring of intervention and time instruction. After that, Kelvin Haston became known as the father of IoT and co-founder of MIT's Auto ID Center. Let's talk about key features and principles of IoT. Connectivity. IoT devices communicate and share data with each other, creating a network of interconnected objects. Sensors. IoT devices use sensors to collect data about their environment, such as temperature, motion, or light. In automation, based on collected data, the IoT system can automatically task and process such controlling light, adjusting temperature, or sending alerts. Data analysis. The data collection collected by the IoT devices is analyzed to provide insights, identifying patterns and make informative decisions. Remote control. Users can monitor and control IoT device remotely from anywhere through the internet access. Scalability. IoT systems can be expanded to include more devices and handle large amount of data, creating interconnected networks of devices. And then we move on to the next topic, IoT architecture. Typically, IoT architectures follows a four-layer model: perception layer, network layer, processing layer, and application layer. In perception layer, the device captures the data from the environment via sensors. In network layers, which is used for communicate to transmit this data through via Wi-Fi or Bluetooth. In the processing layer, the data are processed either at the edge or in the computer. The last layer, application layer. This is the user-facing layer where all insights are delivered. We already talked about sensors and actuators. Now we see examples of it. Common examples include temperature sensor for HVAC systems, motion sensor for security systems, and proximity sensor for parking system. In actuators, they respond to the processed data by controlling devices like motors, valves, and lights, enabling IoT system to take actions like turn on the application, adjusting settings, and moving mechanical parts. Let's see embedded system in IoT. How the embedded system and IoT is related. Embedded systems are the core of IoT devices. These integrating sensors, actuators, and other communication modules, where they are collecting the data, then process it, and transmit the data which enables the IoT device to perform a specific task automatically within the network. And we move on to the microcontrollers in IoT. There are four important terms: connectivity, power efficiency, processing power, and cost. Let's see one by one. Connectivity. Building Wi-Fi, Bluetooth, or other communication protocols. Power efficiency, low power consumption for battery operated devices. Next, processing power, sufficient to handle sensor data and real time processing. Cost, balance between features and budget for the specific IoT projects. This is the most important one. And IoT security challenge. With great power comes great responsibility. Security remains one of the biggest challenges, with risks like data breaches, device hijacking, and firmware vulnerabilities. Data breaches, unauthorized access to sensitive data collected by the IoT devices, and device hijacking. Hackers take control of IoT devices to disturb operation or launching attacks of the devices. Weak authentication, use of weak or default passwords in the devices, making the devices vulnerable to direct approach attacks. And finally, firmware vulnerabilities, outdated or insecure firmware that can be exploited by attackers. So, it's crucial to incorporate security communication protocols and strong authentication measures into the IoT system. Next, power management in embedded system IoT devices. We have to manage the power to improve the efficiency of the device. Let's see one by one. Low power mode. Use deep sleep mode or sleep mode in microcontrollers to minimize energy consumption when the device is inactive, which reduces the power consumption. And energy efficient protocols. Implementing weightless communication protocols like Zigbee or LoRa that consumes low power. Duty cycling, alternating between active and sleep states to limit energy use, especially in devices that do not need to run continuously. Finally, energy harvesting, using of reused renewable energies to power devices, which reducing the dependency of batteries, for example, solar powers. Then we'll see IoT cloud platforms. There are many platforms are available, but and just take three platforms. AWS IoT is nothing but Amazon Web Service, and Microsoft Azure IoT is from Microsoft Service. Google Cloud Google Cloud is from Google Service. Next, we will see data management in IoT. Data collection, data storage, and data analysis. Data collection is done by the sensors, and the data storage is done by the cloud platforms. The data analysis is processing of data for quick decision making using the applications like industry automation or smart traffic. Then the IoT analytics and machine learning. This analytics and machine learning in IoT used in various terms such as predictive maintenance, automation, real-time decision making, and historical data collections. Now we see some IoT use cases. Real-world examples of IoT includes smart home, where devices like thermostats and smart lights. Thermostats automatically adjust the temperatures settings based on the user preference, and smart lights automatically adjust based on the motion or daylight, which these two will helps to save the energy and also use to energy efficient. In industries where IoT is used for real-time monitoring, predictive maintenance, and processing optimization. In healthcare side, IoT enables the patient care, remote monitoring by wearable devices and reducing hospital visits, improved efficiency and drug management. These are the commonly used use cases of healthcare. Looking ahead, the future of embedded system and IoT. The future of embedded system and IoT looks brighter. These systems will become smart by using AI to make quick decisions with the data they collect. As the technology improves, device will work faster and connect better, especially with rollout of 5G. This means we will see more smart houses, cities, and healthcare solutions that make our lives easier. Emerging trends. The emerging technologies like 5G, artificial intelligence, and even blockchains are set to play significant role in expanding IoT capabilities. For instance, AI will help device become smarter, while 5G will provide the ultra fast, low latency connectivity need for real time applications like automotive vehicles. Real world project example: manufacturing. Siemens Minds Mindsphere platform integrates IoT with embedded system to monitor the machinery, data collection, and optimize the manufacturing process. In healthcare, Medtronic uses the IoT enabled embedded system in insulin pumps to monitor blood glucose level in diabetic patients. In agriculture, John Drive use embedded IoT system in their smart farming equipment. We use many platforms to simulate the embedded system. I would like to show some platforms. First, I would like to show walk. This is the interface of Walktree. We can use all these microcontrollers. Here we see Arduino ESP32, Raspberry Pi, STM3. These are the microcontrollers we are used in embedded system for beginning to make projects. This will help to practice as an embedded system engineer or designer. We have to log in with this platform. I already have an account in it. We'll see a sample. Here you will see I'm just connecting four LEDs with the Arduino board. We make a white setup and white loop. This is the setup function which pins we are using, and white loop which provides the function repeatedly follows this. Here we see a triangle which is used to start the simulation, and this plus button you have some components like sensors. Here you see ultrasonic sensor, THT22, temperature sensor, PIR's motion sensor, analog temperature sensors. Here some sensors are available in this platform, and some actuators also here like thermometer, bipolar step motor, like that. Now I'm just play. You will see the alternative lights are blue. It's a simple example for the beginners who wants to design a embedded and other platform will Tinkercad. I think most of you know that. Each platform we have to log in. Here you see. Here the Arduino board is there, and the components are in the right. Just like this. If I press the button, each button has different buzzer sounds. So we can also use the sensors which are available here. And some IoT related cloud platforms also there. I'd like to share ThinkSpeak. ThinkSpeak is also a popular platform, but it is a third-party platform. Here I created two channels. Here you can see this is how the data are sent to the cloud. Based on the here I'm connecting temperature and humidity sensors in that code, so I get the temperature and humidity variations in this chart. Okay. Next, I would like to share another platform also. Blink. Blink also a cloud platform which we can use it for free, but it has some limitations. This will help you to make your IoT and embedded projects more efficient and useful. So these are the platforms which we use, and now we move on to the slides. Examples of successful IoT development. First, connecting vehicles. Tesla uses IoT and embedded systems in its electrical cars with autonomous driving features. Smart homes. Google Nest has successfully developed smart thermostatics cameras and doorbells using IoT. Retail, supply chain. Amazon uses IoT in their warehouse where QR robots which automate products picking and packing process. Energy. General Electric develops smart meters in energy grids, embedded system and monitoring energy consumption and optimizing energy efficiency. In conclusion, embedded system and IoTs are revolutionary how we interact with the world around us, from smart homes to industrial automation. These technologies are creating more efficient, connected, and intelligent systems. I hope this session gave you valuable insights into how embedded system and IoT can shape the future of technology. Thank you all for joining me this today's webinar. I hope you found this session informative and inspiring. I would be happy to take any questions you might have now. If you have any questions,
Banupriya, questions are in chat box. Participants, you can unmute your mic and ask questions.
if you
Hi, I have a question. Is the uh, IoT optimized for blockchain? Actually, it's pretty expensive on the CPU as far as I'm concerned. So, how is it implemented into the current embedded systems? So it is not killing the CPU at all.
not understand your question, only explain. Hello, are you there? Hello, or else hello.
Yes, Banupriya.
We will go to the quiz.
Yes.
Okay, we'll start the quiz. This is the code. Participants are requested to join the quiz.
I know how to join the quiz.
Enter the code or scan the QR code available in my screen. Participants are requested to join the quiz.
Hello, sister.
Banupriya?
Yes.
Yes, you can copy the link and post in chat box. Banupriya, when are you going to start the quiz?
Let's start the quiz.
Yeah, when you going to start the quiz? Shall we start at 7:40?
Yes.
Banupriya, you can start the quiz.
Okay. Congratulations. What did I miss? Okay. Thank you for attending this session. It's a pleasure to me to conduct this, and thank you for all of you who are all participating. Thank you.
Thank you, Banupriya, for conducting the session. Guys, kindly fill the certificate form and the feedback form. Subhasri, please conclude the meeting.
As we come to the conclusion of this enriched and informative section, I would like to extend my heartfelt gratitude to our esteemed speaker, Ms. Banupriya K. Your depth in the knowledge of embedded system and IoT, along with your passion of this technology, has made this section truly engaging and insightful. I hope this webinar would not have been bounded to your understanding about embedded system and IoT. And we are insightful. Thank you for your time and effort today. I had also thanked Ms. Priyadashni for delivering a warm welcome introduction. Your thoughtful words set a positive tone of this section, and we are greatly appreciate the energy you brought to the beginning of this event. A huge thanks to all the participants who are all joined even during a holiday. Your enthusiasm, active participation, and truthful questions played their critical role in the making this section interactive and meaningful. It's your curiosity and engagement that makes this event truly special. I had also liked the knowledge, the incredible work of organizing team of intendants, the effect, dedication, and attention detail that went into the planning of execution. This webinar were expeditionary, and without your hard work being this screen, today's webinar would not have been possible. Once again, thank you to everyone for contributing to making this section and resolving success. And we are forward to continuous participation in our future webinars. Stay connection and keep learning. Thank you.
Thank you, Subhasri, for your attendance. Guys, you can leave the meeting.